Before we learn about the factor theorem, let's remember something. If we have a polynomial and we want to divide it by a binomial and we want to use synthetic division, we would look at the second term and figure out what the value for a is. The value for a will be the opposite sign of this second term of the binomial. So here, this tells us that a is -2. So we'll take that -2 and we will put it here in this little half box. And then we will look up here at the polynomial that we have here, and we'll write down the coefficients. We'll fill in any zeros for exponents that were skipped. So we have 3x to the fourth, 6x cubed, 0x squared, a -5x, and a -10. Then we can use synthetic division by bringing down the first term. Multiply that times -2, you get -6, and add. So that adds to 0. 0 times -2 is 0, plus 0 is 0. Again, 0 times -2 is 0. But plus -5, we get -5, and -5 times -2 is 10, and 10 plus -10 is 0. This last number here is what is our remainder, which here we have no remainder at all. So if we have no remainder, that means that this divided quite nicely, and we can figure out that this right here tells us that we had an x to the fourth, we divided out an x, so our answer would be 3x cubed. We have 0x squared, 0x, but then we have a -5. So -5. So you can see it divided really well. This remainder of 0 is what we're going to be looking at whenever we have the factor theorem. So if there's a remainder of 0, that means that if a is -2, that x plus 2 is a factor of this polynomial. So here we have the factor theorem. The theorem states for any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. So for example, because p of 1 is 1 squared minus 1 equals 0, x minus 1 is a factor of p of x where p of x is x squared minus 1. Let's look at a couple of examples. So let's determine whether a linear binomial is a factor of this polynomial. So for a, we have x minus 3 and the polynomial x squared plus 2x minus 3. So let's find p of 3. Since -3 is up here in our binomial, so the a value would be 3. So let's use synthetic substitution. So that means we take the 3, and then we line up our coefficients of 1x squared plus 2x minus 3. Bring down the first term, 1. 1 times 3 is 3, plus 2 is 5. 5 times 3 is 15, plus -3 is 12. Here, my remainder is 12, or you could say p of 3 is 12. But since that does not equal 0, that means that x minus 3 is not a factor of p of x, where p of x is x squared plus 2x minus 3. Let's check out another example. So here we have another polynomial with a binomial of x plus 4. We're checking for if x plus 4 is a factor of p of x. So let's check for p of -4. So we have -4. Line up your coefficients. So we have 2x to the fourth plus 8x cubed. We skip the x squared, so we have 0x squared, then plus 2x plus 8. Bring down the first term and multiply and add. So 2 times -4 is -8, plus 8 is 0. Times -4 is 0, plus 0 is 0. Times -4 is still 0, which adds to 2, and 2 times -4 is -8, and that adds to 0. So because p of -4 is equal to 0, that means that x plus 4 is a factor of p of x.